Hello friends, let us look into today's syllabus. The syllabus for network and cyber security as given by VTU consists of the 5 modules here, and we know that the syllabus covers 40 hours and also has 3 hours per week. It has maximum 80 marks as external and 20 marks for internal and 3 hours of exams. Also, there are various outcomes and objectives framed for this particular subject, and the textbooks and references are mentioned in the VTU section. Course objectives are as given below. The first objective is know about security concerns in email and internet protocol. The second objective is understand cyber security concepts. Third objective is list the problems that can arise in cyber security. And fourth is to discuss the various cyber security frameworks. Similarly, you should know at the end of the course what you are supposed to have understood or learnt. So these are the descriptions of the 5 outcomes. You are expected to know the network security protocols, the basic concepts of cyber security, and also discuss various cyber security problems, explain enterprise security framework, and apply the security framework in computer system. The level of learning is limited to L1 and L2. Practical. The textbook and reference books. In the textbook, we have William Stallings, Cryptography and Network Security Principles and Best Practices. Then the second textbook is Thomas J. Mowbray, cyber security. This will deal with cyber security. So basically your whole module is divided into network and the other is the cyber security. We have other reference books that are given in the syllabus. This is Cryptography and Network Security, and one more reference book, Cryptography and Network Security by Atul Kahate, which you have to refer. There are some prerequisites for this particular course. The prerequisites are you're expected to know computer communication network, which I have already learned in earlier semester, which basically in that you're supposed to know the computer networking basics and the OSI model. Also, you should be familiar with network security, which deals with cyber modules, web security considerations, and also the secure socket logic, SSL, the history, and some of it. These prerequisites, let us go one by one. So the first one is Computer Communication Network, CCN. In that, computer network basics, what it is. The other two will deal with in the next lecture. In computer networking basics, we have a network which is nothing but a set of computers which are communicating over an internet. We are in a time where business are more digitally advanced than ever, and as technology improves organization security postures, it must be enhanced as well. And if we do not do that, if there is a failure, then we are basically losing out on data, and we have seen that many business labs because of this. Coming to this, next is the OSI model. This OSI model you should be really familiar with. So we will learn about the OSI model in detail in this particular. Here, let us look at OSI, that is Open System Interconnection Model. In this model, there are basically 7 layers. The first one is application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. So these are the 7 OSI models which are connected with each other, and this figure tells you the basically the difference between OSI versus the TCP/IP layer. So we can see that the first 3, application, presentation and session, is represented as the application process layer in TCP/IP, whereas the transport layer is transport, the network layer in OSI is same as internet layer in TCP/IP, The data link layer is nothing but the data link layer. This additional physical layer is also here, but it is interconnected. And this is how we can basically represent the OSI 7-layer model. So here we can see that we have a device A which needs to communicate with device B, whereas there are two intermediate nodes in between the two devices for communication, let's say. So if device A has to communicate with device B, it will start the OSI model here. From the application, the data is sent to presentation, then it sends to session layer, the transport layer, network layer, data link layer and physical layer. Now these data also, if you see, it goes to the intermediate nodes, and these intermediate nodes will also have the network, the data link and the physical layer, and then they are transmitted to the device B through these nodes, and then the data starts in the reverse direction from physical to data to network to transport to session to presentation, application, and the process where it is going to be utilized. So in this way, then it's just an example how OSI layer comes into picture. Here we see the realization of the communication that I was talking to you. Application process 1 begins in this arrow as it has been shown. Then it goes to the system 1, then the data transmission, system 2, and then it goes to the process application process where it is meant to go. There you can see the data is being also increasing at every layer with different packets to frame conversion at the data link, and then it goes through the network and then to the computer or system to where it has to be communicated. Here, let us look into the OSI model a little more elaborately. The first layer, the application layer, we have the 7 layers. We have the presentation layer, session layer, transport layer, network layer, data link layer, physical layer. We have seen all this in the previous slides. Let us look a little deeply what are these layers basically consisting of. If you look at the application layer, the application programs such as Firefox, Internet Explorer, Chrome, Skype, etc. These are basically residing in the application layer. Of course, they are basically using the protocols which are there present in the application layer in this OSI model. So next is the presentation layer. In the presentation layer, basically there are three things that are happening: the translation, compression, and the encryption. In the translation, the data which is in the form of machine level language ones and zeros, or in the form of ASCII, that is a 128 character American Standard Code for information interchange, that can be converted to an ABCDIC, that is extended binary coded decimal interchange code, which is an 8 character. So translation of this form can happen, followed by the compression. Let's say if the file is of an 5 MB file, it gets compressed to 2 MB file, and it is faster there for data transmission, followed by encryption, which is done by SSL, that is secure socket layer. So this happens in the presentation layer. Let us look now in the session layer. The session layer keeps a track of all the files that are downloaded. Example web pages, text images in the form of say data packets, and keeps management uh, track of all the session management. It basically has the session management, authentication, authorization. So when I talk about your authentication, that is just before a connection is established with the server performs a function called as authentication, that is verifying who you are, and which matches the username password if matched connection is established between the user and the server. So this is what happens in the session layer. Next is the transport layer. In transport layer, the data gets segmented into a number of data units. Data units basically has the port numbering, which is basically for the source and destination, and also has the sequence number. Okay, then so basically the data gets into a number, segments get into a set of data units. There is also something called as a flow control that will happen. This is required. Let's say a server sends a data to a mobile at 50 mega Mbps, and the mobile communication is a slower one, and it is say communicates at 10 Mbps. So what it does is, in the flow control, a communication is sent to the transport layer to slow down the data transfer to the server. It also has an error control, so that the error control layer checksum is added to each group of data to check for received, missing, or any corrupted data. Next is the transport layer, where you have the protocols TCP, that is transmission control protocol, which is a connection oriented transmission, and UDP, that is user datagram protocol, which is basically the connectionless transmission. UDP does not provide feedback, and hence it is faster than TCP, which provides feedback, and hence slow, and so data is transmitted very slowly in TCP. Okay, next layer is the network layer, which is basically consisting of the logical addressing, routing, and path determination. The IP addresses in logical addressing, the IP addresses IPv4, IPv6, these are all done and used. In routing, they try to find the shortest path that can be done, and also these path determination, there are different methods: open shortest path first, border gateway protocol. Like that, there are different algorithms with which the path determination can be done. Now the data packets from the network layer are now, these packets are now sent to data layer, where these data are converted into frames, where the MAC, that is address, which is a 12-digit alphanumerical, this is embedded in the NIC of the computer by the manufacturer. So it forms this frame, and it provides the means to send the data to the physical layer. So once it comes to physical layer, then we know that the data now gets converted, which is in the binary format, gets converted into the signals that needs to be connected to. Let's say if it is a wire, it may send a signal, or if it is a light or through an optical, then it converts into an optical, or it just goes to the radio. So appropriate signals are converted here, and at the receiver end, these signals are reconstructed into form bits, and then bits get converted to frame, and then it will reach the application layer from the physical layer onwards. So with this, we have explained the OSI model on the of the communication network. There is a YouTube for you. This YouTube will elaborately tell you how this OSI layer functions in an animated format. It's a good video. You can have a look at it. So next we will be looking into the network security, and with this I would like to end my first lecture giving you the prerequisites on OSI model, and thank you for your patience.